Bismillahirrahmanirrahim. This is Engineer Masood Akhtakiani, and welcome to everybody. And today we have the technical session number 12, pre-stressed concrete and the elements. In this subject, we will discuss about the design of the product, mixed design, advantages, disadvantages, installation, and general features of the products we will discuss. So, what is the pre-stressed concrete and how does it work? Prestressed concrete is a form of concrete where initial compression strength is given in the concrete before applying the external load, so that stress from external load are continued in desired way during the service period. So this initial compression strength is introduced by the strength steel wire alloys called tendons located in the concrete section. So this will be provide the high tension and high performance tensile and elongation strength as compared to the normal steel. So mixed design, mixed proportions. This mixed proportion of the concrete incorporating GGBS 65%, which is the slag cement, and the GGBS with wire with steel fibers 56%, and 0.7% steel fibers were determined through the series laboratories test based on the analysis life cycle assessment. The use of GGBS was considered as a eco-friendly material aimed of reducing CO2 emission and energy assumption, as well as the enhance the durability performance of the products like railway sleepers and bridge girders and etc. Steel fibers improve the durability and the structural performance in terms of crash control and reduction of spalling, and can replace shear reinforcement. These mixes satisfied the improved flexural capacity as well as the CO2 emission compared. So why pre-stressed concrete is required? Now the question is that why we need the pre-complexity. Okay. Before I get start, let's go to back. Some of the basis of the we know the concrete is a good compression strength at very weak in tension. And so we see after external loading, it is a bottom part of the concrete, a tension zone occurred. So it tries to elongate, and guess what? Its cracks or not, or what are the position and what is the stability of the products. This is why we add some steel bars at the bottom section so that it can resist most of the tension and save concrete from cracking. This is our traditional RC structure, but about the larger beam as the span, some larger beam at span like bridge girders, which are the larger 25 meter, 30 meter, whatever, which is larger span. In that way, the traditional or reinforced concrete structure for this longer beam span, we should provide the larger depth, which is often too much high for the bridge over the rivers. This will be enough space under the bridge for ships and the other general passageway. So here we come to the concept pre-stress concrete. The concept of pre-stress concrete is not a difficult. In fact, the particular of compressioning things is a very older in our day to day life. The basic principle of the pre-stressing was applied to construction phases centuries ago, where ropes of metal bands were wound around the wooden staves to form a barrier. So this was long time ago. It was the usage of the pre-stress concrete. When the bands were tightened, there was under tensile pre-stress, which is in turn create compression pre-stress between the staves and the enable them to resist hoop tension produced by the internal liquid pressure. In both words, the bands and the staves are pre-stressed before they are subject to any service load. So by now, I have had over concept. We have learned why and when we should use the pre-stressed concrete. So how does it work in the life? In the real life, high tensile strength steel wires are inserted in the beam section and they are stretched from both sides. It will be stretched up to a maximum limit to anchored the release. Now the stress tension tendons wants to gain its original length and that tensile stresses are transmitted into the compression stress in the concrete. Now after loading, there are two kinds of forces in the beam: internal pre-stressing force, external. In the external pre-stress force is the dead load and the live load, etc. Pre-stress concrete material is confirming the ASTO, high strength 7 wire strand, high strength steel wire alloys of the grade and the types as specified in the design should be used in pre-stressed concrete. Also, stronger concrete is required in pre-stress than the normal RC. Generally, minimum 28 days cylinder strength should be 5,000 psi minimum. So these types of concrete must be used. So that why this high strength concrete? Well, it is the concrete is not strong enough. It can be cracked or the failed when the pre-stress by the tendon, as well as the high compression strength offer high resistance to the tension and the shear, so that it is desirable for the pre-stressed concrete. Moreover, high strength concrete is less subject to the shrink cracks. It is also a higher modulus of elasticity and the smaller creep strength as the result of loss of pre-stressing is small. So what are the advantages? Whole section of the beam is effectively taking both compression and the tension. Pre-stressing the tendons or the anchoring it's against the concrete produces desirable stress and the strain which survives to reduce the eliminate cracks in the concrete. By increasing the efficiency of the pre-stressing force in the pre-stress elements, the dead load can be countered up to the certain limit, which makes the saving in material cost. Pre-stressing helps improve the ability to work shocks, impact loads, and rupture working loads, etc. Use of high-strength steel and concrete in prestressed concrete elements results in a high and thick members. So advantages in the prestressed concrete is decrease the dead weight, reduce in design load and the cost of the foundation, saving the quantity of material used, suitable for long span than the normal precast element. By using the prestressed concrete is suitable for higher cylinder members, contribute more durability of the concrete. Prestress is a most stiffer during working loads and the RCC of the same depth. By using the prestress, it improves the resistance to cracking. So, and more economic. So there are some disadvantages of the prestressed concrete required use of higher strength concrete and steel and the use of more compatible formwork with rupturing high labor cost. About the disadvantages include the following also: the closer quality control work of the manufacturer, loss in the initial prestressing forces. When the compression force from prestressing are applied to the concrete, it will shorten somewhat, partially relaxing the cable. The result is same reduction in cable tension with the resulting loss in prestressing force. Shrinkage and creep of the concrete add to this effect. Additional stress conditions must be checked in the design, so the stress occurring to the prestress forces first applied and then the prestress losses have been placed, as well as the stresses occurring for different load conditions. Cost of end anchorage devices and the end beams plates that may be required. Pre-tensioning and the post-tensioning, the two general methods of the pre-stressing are established. So pre-tension and the post-tension was illustrated in the section above as we discussed already, with the pre-stress tendons or tension before the concrete was laid. And before the pouring start, it is must to be stretches on the both sides with the high tension. Rope will be the completely tight. So after the concrete have hardened sufficient, the tendons were cut and the pre-stress force was transmitted to the concrete by bond. The method is particularly well suited for the mass production because the casting beds can be constructed several hundred feet long. The tendons can be run off the entire bed length and the use for the casting service beams in a line that same times. So the workability of this concrete is the slump test and temperature control and bleeding, dry shrinkage, whatever the physical properties required for the fresh concrete, this is to be considered. And the hardened concrete as the same for the precast. We are checking the flexural and the compression strength and the durability test is to be conducted. So in general, the pre-stressed concrete is more stronger than the precast and the normal conventional concrete. So these products have the more durable and the load bearing as compared to the normal precast and other concretes. So the girders of the bridges sustain the load by running meter or running feet or whatever according to the local codes is complied. So this was the brief about the pre-stressed concrete today, which is the part of the precast concrete. Precast and pre-stressed, these are the both neighboring types of the concrete and affiliated with each other. And our next session will be the shortcrete of the concrete. Still, we have some subject about the concrete. Once the concrete will finish, we will go for the other one. So thank you very much, and I request you to like and subscribe and press the bell icon. So hopefully we will see each other in next technical session with another subject. So thank you very much, and have a nice day.